So I'm not as charismatic as John, and I'm not as good looking as Evan, but I will try my best. Yeah. So I am a software engineer by trade, and I figured out all this stuff because I was trying to look somewhere I shouldn't look, but legally I'm okay because I was paying the cell phone bill. Just putting that out there. So in case you weren't here last night, why you should let me touch your butt, a presentation? You know, for science. And my hands are silky soft, just like Smirker's. I do give killer butt rubs, and you know, massages are a lot of money. Downsides? Not many. I will make you chocolate chip cookies, but I can't promise that I won't work with them. Line graph, my happiness level, your happiness level, it's a win-win. So again, the positives, you'll enjoy it, I'll enjoy it. You get cookies. No negatives. And the kitten wants you to let me touch your butt too. All right, on with the presentation. Yeah, same. All right, so why on earth would you want to look inside of some iPhone data? I mean, you can get all sorts of interesting information from it. Geolocations, address book data, browsing history. It's all stored on the device, obviously. And I'm going to show you how you can access it fairly easily. Calendar data, find out what they're putting in there. Social network information, because we can. That's a lot of the reason why we do what we do, is because we can. It's interesting to try and get into these sort of things. For the lulz, it's funny. And as Vic said earlier, to catch your no good cheating spouse. Oh, I did. I left out cocksucking. So here's a real practical information about how you do this. My talk assumes that you have somebody that's trusted somewhat, and you can access their computer. So if you can have physical access to their computer, you don't need access to their device. So you just throw into iTunes, and if they're on the same wireless network, their device is going to show up right here in iTunes on the side. You just make sure that they're backing up to the computer, and that they're syncing the phone over Wi-Fi. That way the phone never needs to be connected to the computer, and it automatically backs itself up overnight if it's plugged into a power source. And the one big thing is you need to make sure that encrypt iPhone backup is not turned on, because it'll ask you for a passcode, and then it'll encrypt it with that passcode every single time. And so these are the basic 3 settings that you need to have on the target's computer in order to make this work. So it's not terribly hard. If you know their computer password, or if they don't have a password on their computer, it makes it really easy to just set this up to start automating itself every single day. And then if you do have access to the device, you can just go into the general settings and hit sync now if you've got those settings all set up in iTunes, and it'll automatically just throw a dump of all of their data onto their computer. And now you're probably going to ask, well, where does this data live? There you go. Thank you. Thank you. We got Mac, Windows XP, and Vista Windows 7 paths here. You can see they're all fairly similar. And so you can just go to this folder on the computer, and you'll be able to browse all of their backups. Now, I'm assuming that the audience that I'm talking to today, we're going to be talking about post-exploitation data analysis. So I'm assuming you guys can use Metasploit, get the data from these folders here, and then I'm going to show you how to exploit it. So what kind of data can we get from this backup? Or actually, excuse me, the way that the backup works is the initial sync creates an archive of all the user applications and all the data from the phone. And then everything is unencrypted. Boo. unless an application specifically implements encryption within their own application sandbox, it's going to just use this standard data store that Apple provides for programmers. So, and then subsequent backups overwrite the existing backups. So you'll probably want to automate this process to pull the backup every single morning or something like that if you want to be able to look at what happened from the day before. If they deleted anything, you'll know, and things like that. So, but the biggest problem is that when you look into that folder, everything is obfuscated. So you see we've got a few files here that are named, and then everything else is just a hexadecimal file name. There is some interesting information in the named files that aren't obfuscated. Sort of things like build version of the device, their phone number, operating system serial number of the phone, all of the IMEI numbers for the cell phone records, all sorts of good stuff in there. It also shows you what applications have been deleted recently, and also what applications they all have installed. So that's a bit of interesting information that you can just open it up inside of a plist editor, and if you've got Xcode installed on your machine, it's the default reader. So you just open that up and you can just look at all of this data to get it. So the interesting file is the manifest.mbdb file. And what that does is it's basically telling you what obfuscated file name is associated with what sort of path. But when you open it up, it's not that interesting. So we need to actually extract all the information from it in order to determine where the files live and what sort of data is in it. So, but wouldn't it be great if there was an easily extensible platform that you could use to explore the backups? Police have had the sort of capability from a vendor called CereLite. They've got this device that they can plug your phone into, and essentially it will, if they put it in recovery mode and it pulls an image off of it, and they can analyze that image based on the software that they have on this device, and then they can browse all the data. Essentially this device just pulls the data, and then they'll use another computer back at HQ to actually try and crack into the device. So that's not the approach that I took, simply because I had a semi-trusted source where I could actually get the data that I wanted without having to physically attack the device. But now, because I did this, I decided that I was going to write some software. And I called it Binoculars, and you can get it. It's on github.com/lockfail/binoculars. And essentially, it's just a Ruby application that you can run on the target's computer, and it gives you a web interface to just browse every single thing. And I'm going to show you that here in a minute. So current limitations, it only works on a Mac, and the only reason why is because I don't have a PC installation with iTunes that I can test the file path. It should just work on a PC. Not very mature, and it can't browse the encrypted backups like I was talking about before. If you had that little checkbox checked with a password set, you'd need to know that password and to actually be able to get into those encrypted backups. And it doesn't show raw media files right now. However, you can find those in the file system. It does work. It's extensible. So all you have to do to add, if say you find a new file that's interesting, all you have to do is add a new controller to it and name it and tell me what the obfuscated file name is, and it will automatically add it to the list in the web interface. And if that application is available in the iTunes backup, it will show it and show all the data associated with it. It's open source, GitHub bitches. Send me a pull request. I love contributors on my projects. So it is written in Ruby. It is awesome. It is open source, and it is a work in progress. So remember how I was telling you that the MBDB file was it's a binary file. All you have to do is run ruby parse mbdb.rb and give it a path, and it automatically will turn your file paths into, or your obfuscated files into file paths. You can see I've cut the rope on my iPhone. So once you do that, you can actually run another command, and you'll be able to see everything in its extracted form. So you can go in and look at all the applications. There's the cut the rope, and all of the data that's associated with that application. And this, I just extracted this from my backup last night. Here's something interesting, Facebook. You go in and look at all the Facebook preferences, which are pretty interesting. Oh, look, geolocation sites. There's, yeah. Let's see, here's Facebook Messenger. Oh, look, I sent some audio recordings to my nephew at a concert I was at. And there they all are. I'm actually not sure how what the Facebook site is. It doesn't look like there's a ton of interesting information in this file. McGeeTire.com. I don't know what that is, and I've never been there before. But yeah, audio files that you've used to send to your to people, they're stored permanently in the application's data. Preferences. Look at that, Facebook access token. So let's scroll down here. Oh, here's some Nike Plus stuff. GPS, more GPS data. I can look and see about all of my runs. Right, I'm not going to open that one, but maybe. So let's see, what else do we have? Okay, so here, my Starbucks. We're going through here. I've got a Starbucks card on my phone. Look, they're using Google Analytics to track me in their app. So that's interesting. I can just open that SQL file. Let's see, what else do we have here? Oh, camera roll. Okay, so it looks like here, maybe pictures I've taken. Oh, there's my motorcycle. Shoe on head. Okay, cool. So we've got access to all of the camera roll. There's another one in here. Oh. I think these are screenshots and things I've saved from Safari. Server cabinet. Oh, I don't know why that's there. Oh. Yeah, so. Let's see, what else? Oh, SMS attachments. This could get interesting. All right. Hey, there's, yeah. Hey, I'm not going to go through those because I didn't look at them last night. Let's see. Location D. Location daemon. Consolidated location data. You can look at gyroscope calibrations, where it was done. So this can yield all sorts of interesting information. SQLite. So, and like I said before, it's all unencrypted. If I can find my mouse here. Compass calibrations. Hey, look, timestamps. All sorts of cool information. So now that we've got that all obfuscated, how exactly did we do that? Well, you can see here is opening the manifest file in a hex editor, and you can see we've got most of that information on the side, but some people on Stack Overflow actually spent a lot of time and figured out how to parse this binary file out. They all start with a header, which is just a fixed value that identifies it as an MBDB file. And then there's a record for each one. And so essentially all we do is loop through the entire file and figure out what record belongs to what obfuscated file. And then you can output that into just a text file like I had showed you in the presentation, or you can actually extract it, and I've got an application that'll map everything and extract the file system out into a nice, neat little package for you. So Now that we know all that, we just learned before, application databases. They're everywhere. Any application that uses Apple's core data technology is going to have SQLite databases. SQLite is an open source file-based database engine. It supports most of the SQL query language spec. Apple loves SQLite, and so should you, because it's so easy to get data out of. It is the default data store for core data. Now, application developers can choose to do XML plist, binary plists, or binary files, but I don't know any developer that ever changes that setting. They always just use the default core data store, which is SQLite. And look, all the core iOS applications use it: messages, voicemail, contacts applications. So you can get all of that sort of information. So let's take a look at an interesting file. I like to call it 3DOD, because that's what I would type when I was doing this sort of stuff manually. That's what I would go and type into my Finder, just 3DOD, and it would automatically jump me down to that file, and I'd pull this file, because this was really the only file I was interested in. It's also known as home domain library sms.db, and it contains all text message and iMessage data. So there's a couple different tables in this database. There's a person database that directly maps to the handle ID, and you can see the text, what service they were using, SMS or iMessage. You can see read dates, deliver dates. You can see if it's from you or not. So that makes it really easy to just put a SQL statement on there and just pull out the data you want. Here's some other interesting files. We've got contacts, Google Chrome, which is an interesting one. Nike Plus, so you can see all their runs and see where they've gone, their path. That's all stored in their database. Yelp searches, so you can see if they've been to other cities recently and looked up a restaurant or a bar. It only keeps, the Yelp only keeps a record in their database of the ones you've actually clicked on to look at the details of. And once you've looked at the details, that's permanently stored in that database file for the application. So what if it's not your phone? So long as it doesn't have a passcode on it, you can just plug it into any computer running iTunes. It'll show up on the side, right-click on it, and hit back up, and then wait about a minute or 5, depending on the size of their phone and how much data is on it. My iTunes backup is about 5.5 gigs. But if someone that doesn't, I've been using it for 5 years. So anybody that has a newer iPhone or has reset their iPhone recently, they're not going to have as much data, and so it'll only take a minute or 2. And then you just unplug the phone, put it back. What if it's passcode locked? You get this nice little error message. You've got to have it not unlocked in order to actually back up the data. So that's one kind of bummer about that. So a little bit more about SQLite. Yes, sir. You could capture it over the wireless, but that's a little beyond the scope of this talk. So yeah, but that's another very good attack vector. So recovering items in SQLite. The deleted data is still there, but it's not queryable. To understand how to pull stuff out, you need to understand a little bit about how the internals of SQLite work. You can clean all the deleted data out of a SQLite database by just using this command, SQLite, then your database name, and vacuum. So in SQLite, there's this thing called a free list. It's based on, SQLite has this thing called pages, and so it stores things in pages just so that it reduces the I/O to the device. So anytime you delete something, it just gets moved to the page file for the free list. And then the data is still there, but subsequent insert statements will overwrite all the deleted data. So when you're going through all this stuff, you can't you can't recover things that have already been overwritten, obviously. But this is just a mechanism that SQLite uses to reduce the I/O disk read-write on the SQLite files. So the easiest way to get this stuff is to open it in ASCII mode, scroll to the bottom and look. There's no reliable computational way to get the data out of the deleted data out of a SQLite database. And when you do that, it actually looks like this. But you can see in here, you can see this is a deleted message that I had. I said, hope that helps. So, oh, and then there's, ooh, the famous Rene special. Taco Bell and McRib. So you can see the data that's been deleted, but again, you can't actually pull it out. I've got a friend who's been trying to do regexes on it to pull it out, but so far he's been very unsuccessful, as with most regex problems. So, yeah, string search, yeah. You just run the strings command on it, and you can see where things are. But there is a lot of other data above it that's all stored in strings too. So when you open it in ASCII mode, you get all of the actual data, and then all the way at the bottom is the deleted data. So how do you protect yourself from these sorts of attacks if you don't want people to read your iPhone data backups? Essentially, keep it password protected with a strong non-numeric passcode. It is very easy to shoulder surf a 4-digit passcode on a phone. Android has it a little better with the little symbol that you can do on there, but it's still easy to shoulder surf those. So if the smaller the keyboard, the more letters, the better off you're gonna be. Keep your phone in your possession at all times. Back up to iCloud if you trust Apple with that data. I've been looking for a way to actually log into iCloud and pull this sort of data out of iCloud, but I haven't been successful yet. Or preferably encrypt your local backups. And now, encrypting your local backups isn't going to do anything for you unless your computer is password protected at all times. So you need to make sure you do that, because anybody could just come in, uncheck that little encrypt local backups, and then sync it again, and then the new one is not encrypted. So let me show you this application that I wrote. It's called Binoculars. But first, I want to talk a little bit about the licensing of it. So the license is do what the fuck you want unless you're Dennis Kuntz public license. Everyone except Dennis Kuntz is permitted to copy and distribute verbatim or modified copies of this license document. Changing it is allowed as long as the name is changed. So, under no circumstances shall Dennis Kuntz be granted use of this software source code, documentation, or other related material. Persons dealing in the software agree not to knowingly distribute these materials or any derivative works to Dennis Kuntz. Get the fuck out. I didn't know you were in here. Oh, God. Everyone else just do what the fuck you want. So I made this real big so you guys can see it. It's a really simple application. Essentially, it's a Sinatra Ruby application with a couple views and a couple models and controllers. Essentially, all you have to do to add anything to it is just add something to this folder. And you can see there's Dropbox. There's the file for Dropbox. And when you do that, it automatically adds it to the web application. You can add things to it. Everything is optional except for the file. So in here, you can see I'm defining the file. I'm defining the query that I want to run. So there's everything that I want to pull out. And then I'm just defining columns and a title to make it pretty. So, but you can see we've got notes in here, your passbook, photo locations, recent contacts, which is interesting. You can see people who have recently, who you've recently either text messaged or called or emailed. And it's all stored in this little database, which is very cool. Safari bookmarks, voicemails, Yelp searches, Google Chrome, Google Plus. Yeah, so there's a lot of really interesting information that I've already got in here that you can just immediately use and start browsing these backups. So let me get. Is the what? No, it's the file names are just obfuscated. I'm not sure how Apple actually obfuscates them, but that MBDB file actually just has the correlation in there that you can do. So anyways, once you get it downloaded from GitHub, all you have to do is bundle, and then I already did that last night, and then to run it, you just run shotgun. And then there it is. You can see I'm running a WebEx server on port 9393, and if you bear with me here for a second, I'm going to turn mirroring on so that I can see what I'm doing down here. All right. So now that I've got the server running, I can open my web browser of choice. And then here is the one local unencrypted iOS backup that I have on my machine. It was last backed up on March 14th. So when I click on it, damn. Yes. Of course. Live demo. I should have known. So anyways, I'm not going to be showing you this. It was working last night. Anyways, you can go to github.com/logfail/binoculars, and you can see everything that it does. It's pretty awesome, and I'm really bummed that it didn't work. And I'm not going to spend a bunch of time trying to get it to work. So you can go check it out, look for yourself, and if you want to see it, come see me afterwards, and I'll show you how it actually looks and works. And essentially, it just lists all of those controllers that I showed you with all the files, and it extracts the data using the SQL query that you specify, and then lists all the data. You can look at pictures and everything. So, so yeah, that's without my demo, that's what I got. So yes, I can. So is there any questions? Yes, sir. No, I haven't tried attacking the Bluetooth on it. So I mean, this is obvious, like Smirker was talking about last night. This was the easiest method of entry for me. It's your weakest point right here that I found. So it was easy for me to actually get this backup and then start analyzing the backup and determining all the information that was stored in there. So, yes. They probably are. Like I said, I've been trying to figure out a way to actually get into the iCloud, but I assume that you'd need their Apple ID username and password in order to actually get that, and it's probably encrypted with that data. So far, I haven't been able to find any sort of web service or anything like that that would expose that to the user, but I haven't tried sniffing the traffic for when it actually backs up. So yes. No, it's a lot easier to get this stuff off of jailbroken devices because you've got a shell on a jailbroken device and things like that. But jailbroken devices are backed up to iTunes in the exact same manner that non-jailbroken devices are backed up. So you can get the same exact data from it, except it'll include all of the application data for things like Cydia and all of your hacks and things like that. So, still pending. I've been told by my lawyer that everything that I've done here is completely legal because I was paying for the cell phone bill. Therefore, the phone is mine and the data is mine. No. So I saw another question over here. Yes. That's actually a good question. I'm not sure if there's a cleaner that would get rid of all this stuff. But the biggest thing is that, like, a lot of this data that I'm looking at is essential for these applications to run. It's like if we clean out the messages database, then it will be like you just deleted all your messages all the time and just starting brand new. So if you're a data whore like I am, like, I want all of my data. I don't want to be deleting it. I want message history and stuff like that. So. Yeah, no, there probably is some sort of cleaner like that will go through all your application databases and remove, like, geolocation data and that sort of sensitive information. There was a big stink with Apple last year, I think it was, where they were storing the location of all the cell phone towers that you visited in an unencrypted database. And so that they've since changed that. They only store, like, the last day's worth of data. But that's all data that they have to download again from their servers, and so they were just caching it locally on the device, so that when they would travel back to that location, they wouldn't need to know, they wouldn't need to download the cell phone tower database again for that particular area. So, yes, sir. Yeah, the question was, could you inject information into the backup that would then be pushed back onto the device like an outgoing message? That's an interesting thought. I really had no need to do that. But the only way that they might stop that would be if they're actually doing some sort of checksumming of the backup when they're restoring it back to the device. But backups are typically one way. So it'll back up from the device to the computer. But then the only way you get that information back onto a device is you have to do a restore. So you'd have to do a full wipe and restore of the device to put anything that you've injected into the backup back onto the phone. But it puts it back on exactly the way that it was taken off. So I don't know if that would be possible, but it's an interesting idea. So, yes, sir. Yeah. Right. Yeah. No. This was more or less for my peace of mind, knowing that my course of action was the correct course of action in what I did. But you obviously have to supplement this sort of data with audio recordings and photographs and whatnot in order to build a real case. So, yeah. Yeah. Exactly. Anybody else? All right. Thank you very much.